Hey guys, this is Ed from Mission Impossible. Welcome back to my series on Atari 8-bit assembly language. Today, we're going to go from this to this. Today is going to be episode 6 in the series, and if you're new here, be sure to check out the video down below. I'm going to put a link to the first video so you can see what's going on. We got a lot to do today, so let's get into it. So last time, we got it to where we could have a couple blocks on the screen. Today, the goal is to have a whole bunch more blocks on here and also get some organization going on. Right now, there's a lot of stuff in here and it's starting to get a little bit crowded. So the first thing I want to do is do some organization on this. All right, so we're going to do video number 6 and we're going to say reorganized and more graphics. Okay. So a couple things here. One, these right here are going to be generic memory locations that we're going to be using for other projects as well. So the first thing we want to do is we want to move these to a different file. I'm going to create a new file. I'm going to call it hardware.asm. So I'm going to actually just move this to this hardware.asm file. Okay, so what we're going to do here is I'm going to just import that file. And we're just going to use that ICL, which is the include file. And so what we're going to do is just to make sure that things don't break, I want to reassemble it every time we make a change, just so we make sure that there's nothing broken. Okay, so we have our blocks again. So we have our hardware file. That's great. And we want to possibly move the display list stuff out of here. So I'm going to go ahead and create a new file for that. I'll call it dlist.asm. And I'm going to go ahead and move these because not all of them. These are the ones that we need for the display list. I'm just going to move them over there. And we also need this. And we need this right here. Okay, so now what we can do with this is we can just add onto here the include as well. So what we can do is we can say ICL dlist.asm, and we need to, right now we're calling this right here in here, and we don't want to necessarily be calling it here. So what we want to do is we want to actually create a procedure for this. MADS offers a couple different ways that are built into the assembler. One of them is a macro and another one is a procedure. The thing that's different about a procedure as opposed to a macro is the fact that you can call it with parameters, as well as it makes it so that you can have local variables. Now, right now our program is pretty small and so it's not that big a deal, but as we get bigger, having the ability to pass parameters as well as having local variables is a pretty huge thing. So what we're going to do here is we're going to create a procedure. Let's call it setup screen. Okay. Now, one of the things that you have to do here is you have to use the proc or .proc directive as well as the .endp. Now, when I first did this, when I was first prepping for this, I had forgotten a very important thing, and that was to put an RTS in here. RTS is return from subroutine, and the idea with that is that once it gets called, it's going to return back to where it was called from. And for whatever reason, I thought that just putting the endp on there would end the procedure and everything would be great. That was not the case. And I ran into some major bugs because of it. And it took me a while scratching my head. And I actually read in the manual, calling RTS is up to the programmer and not the assembler. I'm not used to these directives for dealing with procedures. So this was kind of a new thing for me. So learning. All right, so we have an RTS in here. And so what we can do now is we can call setup screen from our programming here. Let's just call it from right here. And really, I mean, it doesn't really matter where we call it in this particular case. So everything still works. That's great. But we can refine this further. So one of the things I wanted to show you is the whole local variables thing, like I was talking about. So when you assemble a program using MADS, it creates a couple of extra files in here. There's a .lab file, a .lst file, as well as your object file or your OBX file. So if we open up the lab file, it's the labels, okay? And it shows you what all the labels are. So we have these SDL, STL, these are the hardware ones that we talked about before. We have our colors that we set up, and we have these blank 8, LMS, JVB, antics, all these things, okay? And so these are all considered global variables. And what we can do with this is we can actually make it so that these are going to be local. And the way we do that is we have it within this procedure. What we can do is we can actually just move this into here. Now, the problem is if we run this, it's going to have an error. And the reason why is because it is now part of these blank 8 LMS, JVB, and all that stuff is part of the setup screen procedure. And this D-list is outside of that, so you can't see these. Now, technically, we could make them see them by saying, setup screen dot blank 8, but we don't want to do that. What we actually want to do is we want to move this inside our procedure, okay? And if we do that, I'm trying to make this look a little cleaner here. Our code is still the same. The NWA and the RTS are still the same, but we've moved this D-list within the procedure as well as these labels in here. So let's try running this again. It assembled this time. Now let's run it, see if it works. Yay. Okay, cool. Now the one distinction I want to make here is if we look at the labels now, notice how all of these have setup underscore screen and then .blank 8, .lms, all of these things. So that means we can use these variable names, blank 8, LMS, and stuff like that in other functions and at the global scope, etc. And we don't have to worry about clobbering these. And that can be a real problem. You don't want to have everything be at the global scope. There's thousands of videos of why that's a bad idea. And of course, in assembly language, we have a limited ability to do that, but I'm going to take whatever we can get here. So we've now cleaned up our display list code in here. And a lot of times what I like to do is I like to put in like a comment block. So we can do some fancy things like this. We can say setup screen, and we can do something like sets up the screen, sets up the display list for the screen, something like that. Okay. And we can do some fanciness. I remember when I was first learning to program, I used to love doing all kinds of fancy things around my procedures and stuff. And, I don't typically do that anymore, but why not? All right, so that looks a little cleaner and saying, okay, this is our setup screen function. Okay, procedure function. I'll use the words interchangeably. In this particular context, it's probably more appropriate to say procedure. So now we're calling setup screen. Now, one of the things that we can do here is we can actually just put that on there. And that's kind of showing to me, at least, that this is a procedure or a function that we're calling. It's a little bit clearer to me what that's doing. And when we get into a case where we're going to have parameters that we're going to be able to pass to these procedures, we'll be able to put them right into here. So we now have one for setting up the screen. Now let's set up one for the colors. Okay. Now this one, I'm probably going to keep it as part of the main program. And the reason why is because we're going to be changing the colors probably within the game. I'm just going to take this. I'm going to move things so that they're a little bit more in the same area. So we have these variables. Now I debated changing these out to where they're not using labels. But I think for right now, I'm just going to keep it this way. And, eventually what we're probably going to want to do is set it up so that we can darken the screen as the player gets further down in the dungeon. But for now, I'm going to keep it this way, and we can obviously change it later on. I'm going to copy our cool little thing here just because it looks neat. And I'm going to say maybe set up colors. And sets up colors. Pretty original there. Whatever. It's just for our use anyway. So we need to also create a procedure for it. I'm going to call it setup colors. And going to do the RTS and the end P for end procedure. And one of the things what we're going to want to do here is notice how we have our code, and then we have a procedure within that code. Now, the deal is that we're not going to want to have that. We're going to want to have this outside of our main loop. So let's cut that and let's put it down, say, here. So now we have this setup colors procedure. We don't need this anymore. We're going to want to call it. So let's do setup colors. Okay, gets rid of some of this white space there. And let's try running that again. Make sure we didn't break anything. Cool. Good to go still. And now we have a couple functions that I want to wrap into procedures as well. So let's do our setting up the character set. Okay. So one of the things that we're going to be focusing on today after we get the organization done is to load in more graphics into the character set. So the next thing to do is set up some procedures for each of these sections here. So one, we are loading in the graphics into the character set. And the second one is to display the map on the screen. So let's continue on, and we're going to set up a loading of the character set. So I'm going to call this load graphics. And we're going to do the same thing. We're going to say load graphics. We're going to do RTS, and then we're going to do an NP. We're going to move this down just like we did the others. And we're going to do load graphics. Now this one we could put above the screen. We could put it below. It really doesn't matter at this point. We're only going to want to call it once, and eventually we're probably going to have like an it type of functionality here. But for now, I'm just going to call it there. Let's make sure it still works. Okay, good to go. All right, let's do the same thing here. Now we have a little bit of cleanup to do down here, but I'll get to that in a minute. So let's do the same thing here with, I'm going to call, so this is for the map that we have right now, which is very little. It's the scene that we have down here, this 1, 2, 1, 2. But I'm going to call it the map. Now we're probably going to want to have a couple different functions for the map because, this is a roguelike, so it's going to need to have some sort of map generation function. So for now, I'm just going to call it display map, and displays the current map. Real inventive here. Okay, and do the same thing. We're going to say proc display map. And I noticed that when I was going through this, I had a 12 in the amount of characters we have here. We really don't have that many. We only have 4. So that's something that was kind of odd to me. So I'm actually just going to change that to 4, at least for now. Hopefully it doesn't break anything. But we're going to say RTS, and we're going to say NP. Now, one other thing that I noticed here is the fact that we're using loop 2. Now, this is one advantage of using procedures, and that we can call this loop. And the other one is called loop as well, but we're not going to clobber each other. So that's one of the major things. We have a local variable now for each of these. So let's move this out, and really doesn't matter where we put this. I'm going to put it right here, and we're going to say display map. Let's go ahead and make sure it still works. Okay, still works. Great. So now we have things broken up into 4 functions here, 4 procedures, and really that's not much here as far as looking at the main code. There's a couple things we want to clean up though, and that is the graphics. Right here, notice how we're calling this care set. Actually, no, we're calling this, notice how we're calling cares here. And that's what we have down here. Now, the deal is that we probably don't want to have it down here. What we're gonna want is we're gonna want to have this in a separate file. And that's one of the major things that we're going to be doing today, other than the reorganization, is setting up a separate graphics file. And I'm actually going to call this, instead of cares, I'm going to call this graphics. Okay. And for now, I'm just going to, move these characters over to it. And instead of cares, I'm just going to call it graphics. We're going to keep modifying this, but for now, just kind of baby steps and working through this. So this load graphics, we're going to want to, instead of cares, we're going to load in graphics. Okay. And right here, we also need to include this file. So we can say graphics.asm. And one of the things we can do is we can group these. It's a very typical thing to put includes at the bottom. It's where a lot of data goes. So I'm just going to go with that and say, all right, so now theoretically we should still work. Let's make sure. Okay, cool. One last thing to clean up here, and that's the scene. Now the scene definitely could be moved within the map here. Where's our function for it? Display map. I'm going to go ahead and put it right here. And instead of scene, I'm actually going to just change the name to map. Okay. We can get rid of some of this white space. And so now we have this map within this display map function. And what we're going to want to do here is probably have something where we're generating this in another function and then displaying it with this function. But for now, this is fine. So yeah, that's looking pretty clean. Okay, let's go ahead and verify that it works. Cool. So we haven't changed any functionality. We've only refactored this so that it's cleaner. Okay. So really, we have it down to 4 functions that we're calling. So next up is to actually set up our graphics. Okay, so right now we have 2 characters that we're using to make our wall texture, right? And so the first thing we're going to want to do with this is, if you notice in the loading of this, that we're loading it in at the start at 8. Okay. And that is to go around the blank character. Okay. And so one of the things that we're going to want to do here is we're going to want to make that blank character as part of our image. I know that sounds a little weird, and I kind of have gone back and forth on this. It's just going to make our the math a lot easier and a lot more straightforward. And in case we wanted to do something quirky, like put a pixel here and there on the background, we totally could. What I'm going to do with this is I'm going to remove this +8, and we're going to change this so that we're going to add characters for the first for the blank. Okay, so we can make it blank by just putting 8 zeros. Okay, so that's 7, 8. We'll put a comment on here, and we're going to just put 0 as being our character. Okay, this one is going to be now the thing is with this, what we can do is we it's now we're going to be off by 1. So what we're probably going to want to do is we're probably going to want to say 0 and 1 are going to be these blanks. Then we're going to have 2, and then we're going to have 3. Okay. And so now all I need to do is in here, instead of going to 16, let's go to 32. Okay. Because we added 2 more characters, even though they're blank. And we also want to change our map characters, because right now we're doing 1 and 2. We're going to want to be doing 2 and 3. Okay, so let's try that out. No change. That's actually what we wanted. But we've reserved space for our blank character. So the reason why I did that is because we're going to want to now go into Photoshop or whatever art program you want and add more graphics. So I've opened up the graphic that we were working on last time into Photoshop, and I've moved it over per what I was just talking about with the leaving space for the space, actually. So both halves of the space character. We have our same wall graphic here. And so what we want to do here is we want to add more graphics. What we're going to want to have here is we're going to have the basics are going to be a wall, a floor, a door, and upstairs and downstairs. With that, we can create whole maps. One thing that's going to make the game a lot more interesting is if we have different types of walls and floors that we can interchange. For now, let's stick to just basics, and then we can add some more color later on. So for now, let's worry about getting a floor. Let's get a door, and let's get stairs up and down. What I kind of came up with as being kind of an interesting way to do a floor is by doing just some patterns. So like if we take our white and we say we're going to do like something like this, and we can do something, we can do some sort of checkerboard kind of thing, but different types of patterns to make this kind of interesting looking. And maybe this doesn't look good, I don't know. But we can do some stuff with dark character or dark gray as well, something like that. Okay, nothing major, but it should look decent. Okay. Another one is going to be our doors. And so I kind of came up with a little bit of a interesting thought here. Don't worry about that. We'll do brown, and we'll just load this in like this, fill in the door. Actually, I think what we want to do is do this instead. We'll just color in the door here, just brown. And we want to kind of put maybe a window in there, maybe like a doorknob. Okay. So next what we want to do is we want to have maybe an upward stair and a downward stair. So let's go with something like this. This is not going to be the right angle. Let's try a steeper angle. So we can definitely go like that. That may be too steep, so we might need to get into some weird stuff there. But like if we did something like this to kind of highlight the stairs, you can do something like that. That might not be too bad, right? And let's do the reverse, just for the stairs down. Obviously, you can do whatever you want. It's your game. And I messed it up. Oh well, we'll figure it out here. That's not right. Okay. We can always fix it though. Actually, no, that is right. Okay. There we go. We have very, very basic. We have a wall, we have a floor, we have a door, we have an upstairs, and we have a downstairs. Really simple. We're good to go. So I'm going to go ahead and save this. Actually have it as graphics.png in this directory that we're working in. Now, one of the things that we need to make sure that we do is that we want to make sure that we are using indexed color. And right now it's sitting at RGB color. So what that means is if you have index color, that means that you have a color palette. And you're not just putting in the file that this is black, this is red, this is blue, whatever the colors are. In RGB color, each pixel has its own value for each of the colors. And that's great if you have millions of colors. We only have 5. And in order to load this image, we're going to want to have only 5. So what we're going to want to do is convert this to indexed color. And we can say, we don't want to do any forcing of colors. Transparency is fine. Actually, probably no transparency at this point. We'll do exact palette, totally fine. Now that save as option probably will be a little different if you're not using Photoshop, but you should probably be able to figure it out. So this is a PNG file that's going to be very, very simple. So in order to get this data into this file, we're going to need a tool to do that. And I've actually written a tool to do this, and it's a Python script actually. So let me load that up. So here is the program that I wrote in Python to be able to load in the graphics and output assembly language. So you don't need to know Python to be able to use this. You do need to install Python on your machine, and you also need to install the ping library. So the way to do that is you run, assuming you have Python installed, you run pip install pyping, and it's going to complain that it's already installed. If you need help with that, I'm sure you can find stuff online on how to install that library and stuff. But it does use that one library. But it does load in this PNG file, which we have created over here. It loads it in and it outputs to the graphics.asm file, which is right here. And I have ran it already, so we can take a look. And basically it's going through and it's loading in similarly to what we had before, in that it's loading in the spaces like we were looking at here. And then it loads in our wall textures, etc. So basically it's going to do all this stuff for us. So that's going to help us dramatically in the future. So now what we have is, in order to build this, we're going to have to run, if we're going to do any changes to the graphics, anytime we do, what we need to do is need to run Python and then tile maker. And of course, I will include this in the repo. So you can just run tile maker and that will update this graphics. So .asm. So if we go to our main .asm, we're still loading in the graphics the same way. Now, one of the things is, because we are loading in the entire character set now, we're going to need to beef up this load graphics function. And so what we're going to do here is we're going to need to do 4 operations instead of 1. So what we're going to do here is we're going to add these right here, and we're going to say +8, +16, and +32. We're just adding each time, and 16 and +32. And we're going to increase here, and we're going to keep going until we hit to 128. So INX is going to increment each time. So we're going to go through here. It's going to be 0. So it's going to be moving, characters 0 and 8 and 16 and 32. And then it's going to go through and it's going to do 1. And it's going to basically do each of these, 4 at a time, instead of just 1 at a time. Now, the reason why we have to do that is because we're going to run into problems if we try to increment X too much, in that it can only hold a certain, highest number is 256. It can only hold 1 byte, and we're going to get way over 1 byte with this. So we have to do it this way in order to do this. So this should work here, and we're not going to see any difference though. And the reason why is because, it has more code in here, obviously, but it's not going to show anything different because we're only still showing this one character twice. But what we can do here is go into here and we can have some fun with this. Let's take a look at the next characters. So we can do like, let's do wall, which is 2 and 3, and then a floor, which is 4 and 5, and then 2 and 3 for the wall. If you know, looking back here, this is 2, this is 3, this is 4, this is 5. Remember how it's 4 pixels wide? So now what we can do, and we're going to need to increase this number so that we can, you know, have all the characters in here. We're going to say file it and assemble it. Now we have a wall plus floor plus wall. That doesn't look half bad, actually. So now we can start really playing with this. So I'm going to make it even wider. Okay. Why not? Just keep going. And this is where the fun really begins. So now I've just added 1, 2, 3, 4, 5, 6, 7, 8 more. So let's go to 14. And let's do this. Cool. So now we can see that, you know, it's tiling. Now, one of the things to keep in mind here is it's not tiling very well. Notice how it kind of does this jagged and then it starts over again. It's okay. We could probably do better, but not too worried about it right now. Well, let's try to make a room. So let's try just doing something simple like let's put walls along the top. And let's make it a full 16 to make the math work out a little bit easier. Does not matter. So we're adding 2 more, but just going to make it a little easier because we can say it was going to be 16. Well, now it's going to be 32 to show this wall up top here, and then this row of, wall and then floor. So let's make sure that looks okay. Okay. So one of the problems here is that we didn't go all the way across, and that's okay. We just need to add some spaces, or we could just add wall. And because basically, if you look at the screen memory, it is contiguous. So it's going to go through the entire first row, and then it's going to go to the next row and stuff like that. So we could either make one big room, or we could make, only half the screen. I'm going to go for the whole thing. So I think I think we decided it's going to be 40 characters across. So since this is, we said that this is 16. So let's go 2 more, and then that way it's going to be a full 20. And so this should be 40 characters across. Let's take a look at that. Okay. All right. And so we are, I know the problem is. So we've now increased it from 32. We now have a bunch more here. So let's go ahead and let's make it all 40 characters across. Just do some nice copy and pasting here. So with that, we're going to say 80 because we have 2 lines. And let's do this. Okay. Starting to really dig this. Okay, let's keep going. Let's add more floor. Let's just make the whole screen one big room, just for fun. Okay. So we now have it, it's kind of brute force method here, but we've got it working here. So we've got, we're going to go through for each character. So 40 characters in a line. And we actually are only going to have 12 lines. So that's what all these are, and it basically does a 40 character offset, or 40 byte offset, I should say. Okay, so here we have our map, and so let's take a look. So now we have walls, and we have the floor, and now let's add just a little bit more details, just because we have the other graphics in here, we might as well use them. So let's add, like in the corner of the room, let's add our stairs, for example. And let's take a look at where those are. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go down, 10, 11. So let's put in our code here, let's put in the lower right-hand corner, let's go 10, 11. Okay, so that's going to be, it's going to be a little bit offset from the wall. Let's take a look at that. Okay, not exactly what we want to see, but it gets the point across, I guess. It's the right graphic, so that's a good thing. You know, we don't have transparency, we don't have anything else like that, but that's okay. It's the right graphic. And let's put maybe let's put it into a room, so with a door on it. So we've got 4, 5, 4, 5, 4, 5. So let's make it 3 by 3, and let's go 2, 3, 2, 3. And obviously we're going to be doing this so that we can automatically generate our map eventually. But for now, we need to be able to have a map in general. Let's put wall here. And now let's make it so that we can get in the room by having a door. So 0, 1, 2, 3, 4, 5, 6, 7 is our door. So let's go ahead and put that here. 6, 7. Okay, let's take a look at that. Okay, it is a green door. That's fine. You know, we wanted it to be a brown door, and that has to do with our the Python script, which we have to adjust the colors. But you get the idea here. We now have a scene. You know, we have something that you can actually it actually kind of looks like a game. There you have it. That's going to be it for this week. We now have the ability to load in graphics, did a little bit of code organization, and yeah, it's starting to really shape up. So until next time, see you in the next adventure. Take care.